Our next lesson will be inverse variation. And this time we'll say if y varies inversely as x, we say y equals k over x. And the process is essentially the same. We'll need to solve for the constant of variation and then use it to solve a problem. So, for example, if we are told, suppose q varies inversely as h, if q equals 4, when h equals 15, find q when h equals 10. So our issue is q varies inversely, so q equals k over h. Now q is 4 when h is 15. So we get 4 is k, plugging in the h of 15, over 15. And we need to do a little bit of algebra to solve for the constant. So multiply both sides by 15. 15 times 4 is 60. So we get 60 equals k. Now our goal is to find q when h equals 10. So we're going to say here again, q equals k over h. The k value we found was 60. The h value here we have is 10. So the answer to that question would be q equals 6. If a varies inversely as the square of b, and if a equals 4 when b equals 3, find a when b equals 2. So a varies inversely as the square, so a is going to equal some multiple k over the square of b over b squared here. Now we're saying a equals 4 when b equals 3, so replacing a with 4 will be k over b squared over 3 squared. So 4 is k over 9. Multiplying both sides by 9, we get 36 as k. And we'd like to use that to solve for the problem. And what does it tell us? It tells us to find a when b equals 2. A varies inversely as the square of b, so a will equal k over b squared. We know that k is 36. And then our goal is to do what? Our goal is to replace b with 2. So we'll get a is 36 over 2 squared. A is 36 over 4. A is 9. The frequency of a vibrating string varies inversely as its length. If a 5-foot long piano string vibrates at 100 cycles per second, What is the frequency of a piano string that is 2.5 feet long? So if you know something about music, you'll recognize that a shorter string will give you a higher pitch, therefore a different frequency. So we are saying the frequency varies inversely as the length. Using our number for this problem, the frequency that we have here is 100 cycles per second, corresponded to a length of what? Of 5 feet. Keeping our units in mind, multiplying both sides by 5, we get 500 equals k. And then making that substitution, again, we're going to say that frequency equals k divided by L. Our goal is to find the frequency for a string that is 2.5 feet long. So the frequency will be k, substituting the k of 500 divided by L divided by 2.5 feet. 500 divided by 2.5 is 200. So the frequency is 200, and keeping our units in mind, that would be 200 cycles per second.